Alright, good day everyone. So welcome back to my channel, and today we'll be talking about derivatives of inverse trigonometric functions. Talks about differential calculus, and this is Kasaligan Vlogs. So we have inverse trigonometric functions forms, or the formula. So take note of this one because we'll be using this one along with as we go along with our topic. So while we are having this topic, inverse of trigonometric functions, we need to familiarize with this T16 to T21. Okay, but it's the T21. So we have here the following. So how did we come up with inverse trigonometric functions forms? So let us have first a concept about this one. So I'll give you a short concept about inverse trigonometric functions. So let us have first this part. So if this is our inverse trigonometric function, y is equal to inverse sine of x. Inverse sine x. So take note that sine inverse sine of this one is not the same as 1 over sine x. No, this is not the same because this symbol is the same as arc sine x. So let us have first this one as y is equal to inverse sine x. So if we're going to transform it to 1, we have here sine y is equal to x. So if sine y is equal to x at this point, so take note in the Cartesian plane, sine is between only negative 1/2 pi here. So this is between, we have here negative 1/2 pi and 1/2 pi positive. So this is between equal to y. So this is the Cartesian plane. So going here and going there. So this is 1/2 pi and this is negative 1/2 pi. So this is the restriction of sine y is equal to x. So if that is, so we're going to take the derivative of this part. So the derivative of this part is equal to cosine y is equal to dx over dy. So this is with respect to y. So cos y is equal to dx over dy, and by the use of d8, so by the use of d8, inverse function rule, so we could have this one as dy over dx is equal to 1 over cos y. So it is being inversed, the dy become dy over dx and 1 over cosine y, that is based on the inverse function rule. So by the use of inverse function rule, so we come up with this formula. So how to find for cos y? So cos y is equal to sine squared y plus cosine squared y is equal to 1. So therefore cos squared y is equal to 1 minus sine squared y. So cos y is equal to the square root of 1 minus sine squared y. This is positive and negative. But we are going to choose the positive side because in this part, positive 1/2 pi and negative 1/2 pi, the cosine is always positive at this time. So positive square root of 1 minus sine squared y. Why is it positive? Here, we're going to illustrate that one. This is x and this is the radius, and this is the radius. Cosine is adjacent over the radius, which is always positive at this part. Okay, x over r here in the negative 180s part, x over r. R is always positive because this is the radius, so therefore positive divided by positive is equal to positive, and positive divided by positive is equal to positive. So therefore we'll make use of positive square root of 1 minus sine squared y. So what is the value for sine? Sine is equal to x. So therefore dy over dx is equal to 1 over the square root of 1 minus x squared. So take note, by the use of this part, since sometimes this is u is differentiable as x, so we could say that dy by the use of 7, which is the chain rule, dy over dx is equal to 1 over the square root of 1 minus x squared. We need to find for the derivative of y, u with respect to x. So du over dx, because u is differentiable to x. Okay, so therefore this is our function. So what is the value for y? Y here is equal to this part. So therefore d over dx of inverse sine of x, inverse sine of x is inverse sine of u here. We'll make it this one as a u because we're using u here. So u is equal to 1 over 1 minus u squared du over dx square root. Okay, so this is the concept behind inverse trigonometric functions. So next we have here differentiate y with respect to x, a is greater than 0. So we have here number 1, y is equal to sine inverse sine of negative 1 3x. Oh no, inverse sine of 3x rather. So that's not negative 1, that is the symbol for inverse rather. Inverse sine of 3x. So to get for inverse sine of 3x, so these are the problems 1 to 7. So we have here y is equal to inverse sine of 3x or arc sine 3x. So very simple for this part. We are just going to find what is the formula for sine, inverse sine. So the formula for inverse sine is equal to inverse sine of u is equal to 1 over the square root of 1 minus u squared du over dx. The first thing that we're going to do is we're going to find the value for u. Since the value for u here is 3x, so u is equal to 3x. So du is equal to 3 dx. So therefore du over dx is equal to 3. So now we could now simply substitute to the given equation. So in the given equation, we have here dy over dx is equal to 1 over the square root of 1 minus the u here is 3x. So we're just going to substitute 3x then squared times the derivative d over dx, which is 3. So this is multiplied by 3. So dy over dx is equal to 1 over the square root of 1 minus 9x squared times 3. So simplify this part. So dy over dx is equal to 1 over the square root of 1 minus 9x squared, that is times 3. So therefore this is the answer. So that's the answer when y is equal to inverse sine of 3x. So that's it for number 1. Okay, let's proceed with number 2. Y is equal to inverse tangent of x over 4. So tangent, see we have here the formula for tangent. Tangent is equal to 1 over 1 plus u squared du over dx. So this is the formula. So first is we're going to find for our u. U is equal to x over 4. And we have here our du is equal to 1/4 dx. So du over dx is equal to 1/4. So by the use of the formula, so dy over dx is equal to 1 over 1 plus, which is our u here is x over 4, and we're going to square times 1/4. Okay. So we have here 1 over 1 plus x squared over 16 times 1/4. So you're going to multiply it by times 4 here. The result of this part is 1 over 1 4 plus, because we're going to multiply here, distribute the 4 here in this part, 4x squared over 4. So dy is equal to 1 over the LCD of this one is 4, and this is 4 divided by 1 times 4, that is 16, plus x squared, because 4 divided by 4, that is equal to 1 times x squared, that is equal to x squared. So therefore dy over dx is equal to 4 over 16 plus x squared. So this is the result when you're going to differentiate y is equal to inverse tangent of x over 4. Okay, that's easy for this part. Okay, so let's proceed now with number 3. So in number 3, y is equal to inverse sine of square root of 1 minus x squared. So the first is we're going to locate the formula. The formula for this one is 1 over the square root of 1 minus u squared du over dx. So first thing that we're going to do is we have to find for u. So u is equal to 1 minus x squared raised to 1 half. We could rewrite it 1 because this is exponent. So du is equal to 1 half, and we have here 1 minus x squared raised to negative 1 half, because you're going to subtract it by 1 times the derivative of this u, which is based using the chain rule. This is negative 2x. So cancel this part. So therefore the remaining of this one dx, the remaining of this one du over dx now is negative x over the square root of 1 minus x squared. So this is the value for our du. So by the use of this part, so we're going to multiply here. Okay. So we have dy over dx is equal to 1 over 1 minus the square root here. Our u here is square root of this part. Or you can have this one as square root of 1 minus x squared. So square root of 1 minus x squared, then we're going to square it here. So times, which is negative x, which is our du here, we're going to multiply. So square root of 1 minus x squared. So we are going to simplify this part. It will become dy over dx is equal to 1 over square root of 1 minus 1 plus x squared times negative x over square root of 1 minus x squared. Okay, so cancel this part. So the remaining of this one is 1 square root of x squared, and this is negative x over the square root of 1 minus x squared. So cancel, because the square root of this part is x. So cancel this part. So therefore the answer is dy over dx is equal to negative 1 over the square root of. Do not forget to write negative here. So we have here 1 minus x squared. So this is dy over dx is equal to negative 1 over square root of 1 minus x squared. So that's it for number 3. Alright, so let's proceed with number 4. In number 4, y is equal to inverse second of square root of 4x plus 1. See, so we are going to cite for the formula for this part. So the formula for inverse here is, we have here 1 over u squared of u squared minus 1 du over dx. Okay, so y is equal to inverse sec of square root of 4x plus 1. So we're going to locate first our u. We could express this one as 4x plus 1 raised to 1 half. So therefore du over dx here, so we have 1 half 4x plus 1 raised to negative 1 half times the derivative of this part, which is, okay, the derivative of this part is equal to, okay, so that is 4x plus 1 is equal to 4. So we have here, cancel this part. So we have 2 square root of 4x plus 1. So dy over dx. No, du over dx rather. du over dx. So 2 over the square root of 4x plus 1. So we're going to substitute here by the use of dy over dx. So 1, our u here is square root. So square root of 4x plus 1 times u squared. Okay, we're going to multiply here. Square root of 4x plus 1, then still we square minus 1 times the derivative of this part, which is d over dx, is 2 over square root of 4x plus 1. Okay, so now we can multiply this part here. So this is dy over dx. So this is multiplication. So 2 over 4x plus 1 here, because square root times square root, that is mawawala 1 half plus 1 half is equal to 1. So therefore 4x plus 1, and we have to simplify the inner part. The square root of this will become 4x plus 1 minus 1, because this is square root. So the remaining of this part is 2 over 4x plus 1 times the square root of 4x. So the square root of 4x is equal to 2 over 4x plus 1 times 2 square root of x. So cancel this part. So I have 2 over 4x plus 1 times the square root of x. So to mawala yung x, square root of x, you have to multiply it by square root of x over the square root of x based on algebra. So dy over dx is equal to, this will become 2 square root of x over, so this is cancelled, right? This is 1, by the way. So this is none. So square root of x, this is 4x plus 1 times x. So this is the answer. Square root of x, this over 4x plus 1 times x. So that's all about number 4. Okay, so let's proceed with number 5. In number 5, the square root of a squared minus x squared, a cosine inverse cosine of x over a. If the first thing that we're going to do is we're going to separate derivative of this part. Okay, so for me, I have to separate this part. Okay, so this is the square root of a squared minus x squared. So if we're going to take the derivative of this part, so this will become a squared minus x squared raised to 1 half. So if you're going to take the derivative of this part, so this is 1 half a squared minus x squared raised to negative 1 half times the derivative of this part is negative 2x. So cancel this part. So this is negative x over the square root of a squared minus x squared. So this is the derivative of here, the first part. Next is we're going to take the derivative of the second part. The derivative of the second part is a cosine of inverse cosine of x over a. So this is in the form of cosine is in the form of negative 1 over the square root of 1 minus u squared du over dx. So we're going to find first our u here. Our u is equal to x over a. So therefore du over dx is equal to 1 over a. So 1 over a, if that is our u, du over dx, so therefore we're just going to multiply here. So a times negative 1 over the square root of 1 minus our u is x over a squared, then multiply it by our du, which is 1 over a. So cancel this part. Alright, so now if we're going to simplify this part, so this is negative 1 over the square root of 1 minus x squared over a squared. So simplify further. So that would be equal to negative 1 over the square root of a squared minus x squared, because a squared divided by 1 the squared is a squared, and a squared minus x squared. So therefore this is negative 1 over the square root of a squared minus x squared, and this becomes the square root of this part is over a, and this is negative 1, this is a rather, over the square root of a squared minus x squared. So these are the derivative of this part, and this is also the derivative. We have to copy this part in order to get the full derivative of number 5. So we have here copy. So copy first, we have y is equal to, okay, so dy rather, dy, so y is equal to, the given here is the square root of a squared minus x squared minus a cosine, inverse cosine of x over a. So therefore dy over dx, the result of this one is negative, okay, so we're just going to copy. So this is negative x over square root of a squared minus x squared. Then plus, the second part here is negative a, okay, so minus, so the negative, so may masang plus, maging plus ito, a over the square root of a squared minus x squared. So now these are the derivatives that we got from this part. So by chop. So dy over dx is equal to negative x plus a over the square root of a squared minus x squared. So we have to calculate this part, a minus x over, we could factor this part as a minus x, and this is a plus x square root. Okay, so this is a minus x, that is equal to 1 here. So therefore we could have 1 minus 1 half, because this is 1 half. If we're going to make this one square it into 1 half, so we have here a minus x over square root, because this is equal to 1 half. Ang square root natin nasa babaw na, diba? Over the square root of a plus x. So therefore, the square root of a minus x over a plus x. Again, this is, we could express this one as a minus x raised to 1 over a minus x raised to 1 half and a plus x raised to 1 half. So ganito, 1 minus 1 half. So, greater ang exponent here sa top. So, therefore, ang a minus x nasa ibabaw na. So, therefore, this is dy over dx. So, that's the result for this part number 5. Okay, square root of 1a minus x over a plus x. Okay, so let's proceed now with number 6. In number 6, we're going to chop again this part. We have to find the derivative of this one and the derivative of this part. So for me, that's what I'm going to do every time that I will have this kind of problem. So we have here first, so by the use of d4 here, because this is our u and this is our v, d4 is equal to u dv over dx plus v du over dx. So now, by the use of this part, we take first our u, which is x minus 1. Our du over dx is equal to 1. So first, you have your v. V is equal to 2x minus x squared raised to 1 half. So we're going to take the derivative of v with respect to x. We have here 1 half times 2x minus x squared raised to negative 1 half over times rather, so negative 2x plus 2. So we could factor this part as negative 2, alright, we have here 2 rather, to negative x plus 2. Plus 1 rather, plus 1. Okay, so 2, cancel this part. So we have here negative x plus 1 over the square root of 2x minus x squared. So dv over dx. So now we are going to take the d4. So in d4, our u here is x minus 1 times the derivative of dv, which is negative x plus 1 over the square root of 2x minus x squared. Then plus our v here is here the square root of 2x minus x squared, then times the derivative of this part, which is 1. So if we're going to multiply this part, this is negative x squared, okay, negative x squared plus x and minus 1. Okay, so plus x over the square root of 2x minus x squared, and this is plus the square root of 2x minus x squared. So we are going to combine this part. We have negative x squared plus 2x minus 1 over the square root of 2x minus 1, 2x squared, plus the square root of 2x minus x squared. Try to have this LCD. So we have here 2x square root minus x squared. So this is negative x squared plus 2x minus 1. Then square root of this part divided square root plus 2x minus x squared. So we have here the result of this part is equal to negative 2x squared plus 4x minus 1 over the square root of 2x minus x squared. So this is the derivative of this part here. Okay, so again, that is negative 2x squared plus 4x minus 1 over the square root of 2x minus x squared. So let's proceed with inverse sine of x minus 1. In inverse sine x minus 1, okay, so the formula for this part is 1 over the square root of 1 minus u squared du over dx. So our u here is x minus 1. Our du is equal, d over dx is equal to 1. So now by simply substituting here the value, so 1 over the square root of 1 minus x minus 1 squared times the derivative of 1, which is a derivative of u, which is 1. So therefore we have here 1 over the square root of 1 minus x squared minus 2x plus 1. So if we're going to expand this part, the result of this is by algebra x squared minus 2x plus 1. Okay, so next we have here simplify. So 1 over, if we're going to distribute this 1, this will become the square root of 1 minus x squared plus 2x minus 1. So the remaining is 1 over the square root of, cancel this part, 2x minus x squared. So this is the derivative of inverse sine. So next we have going to combine. By the use of this, we are going to combine the two derivatives here. Okay, ito. So therefore, we have dy over dx. If we're going to copy the result, we have negative 2x squared plus 4x minus 1 over the square root of 2x minus x squared plus, here the result of inverse sine, 1 over the square root of 2x minus x squared. So we're going to combine this part. You have negative 2x squared plus 4x minus 1 plus 1, because the same denominator, over the square root of 2x minus x squared. So cancel this part. We can factor this also. So we have here 2. 2 is equal to 2x minus x squared. If we're going to rearrange this part, over the square root of 2x minus x squared. We can express this one as 2x minus 1, x squared rather, raised to 1 over, we have here 2x minus x squared raised to 1 half. Same base here, so 1 half, 1 minus 1 half, that is equal to 1 half. So therefore, this will become 2x minus x squared raised to 1 half. This is positive, so therefore we can express this one 2 the square root of 2x minus x squared. So dy over dx. So this is the result for this number. So 2 the square root of 2x minus x squared. Okay, so let's have the last number, which is number 7. In number 7, this is the same concept with the last number, but this is a product still. So have here in this part. So we have here d4 again. d4 is equal to derivative u dv dx plus v du over dx. So first is we're going to find the u here, and this is our v. Our u is equal to x, our du over dx is equal to 1. Next we have here our v is equal to, we can express this one as 1 minus 4x squared raised to 1 half. So dv over dx is equal to 1 half 1 minus 4x squared raised to negative 1 half times negative 8x, the derivative of u. So cancel this part. So this is negative 4x over the square root of 1 minus 4x squared. Okay, so apply now here in d4. So u here is x times derivative of v, which is negative 4x over the square root of 1 minus 4x squared times plus, we have here v is equal to the square root of 1 minus 4x squared times the derivative of 1. Derivative of u, which is 1. So this is negative 4x squared over the square root of 1 minus 4x squared plus the square root of 1 minus 4x squared. So take the LCD, square root. So 1 minus 4x squared, this is negative 4x squared because we're going to divide here, still 1, and plus 1 minus 4x squared. So the remaining of this part is equal to negative 8x squared plus 1 over the square root of 1 minus 4x squared. So this is the derivative of this part. Now we are going to take the derivative of this part. So next page. The derivative of 1/2, this is sine, inverse sine of 2x. So the formula for this part is 1 over the square root of 1 minus u squared du over dx. So now we are going to combine, we're going to get the u here, which is 2x, du over dx is equal to 2. So by substitution, we have here 1 over the square root of 1 minus 2x squared times the derivative, which is u, du over dx, which is 2. So therefore, this is 2 over the square root of 1 minus 4x squared. So this is the derivative of this part. So since this is preceded by 1/2 rather, so this would become 1/2. So 2 over square root of 1 minus 4x squared. So cancel this part. So this is 1 over the square root of 1 minus 4x squared. So take note, preceded by 1/2. Okay, so now we're going to combine the two derivatives, which is this part, and the second one is this part, the simplified part. So dy over dx, we're going to copy this part, which is negative x squared plus 1 over 1 minus 4x squared. So this is negative 8x squared plus 1 over the square root of 1 minus 4x squared plus 1 over the square root of 1 minus 4x squared. So this will become dy over dx is equal to negative 8x squared plus 1 over the square root of 1 minus 4x squared, same LCD. So this is dy over dx is equal to negative 8x squared plus 2 over the square root of 1 minus 4x squared. So we could factor this one, dy over dx is equal to negative 4x squared plus 1 over the square root of 1 minus 4x squared. Dy over dx, we could simplify first this one further, which is 2. This is 1 minus 4x squared raised to 1 over 1 minus 4x squared raised to 1/2. So 1 minus 1/2, that is equal to 1/2. So therefore, dy over dx is equal to 2, 1 minus 4x squared raised to 1/2. Positive ang 1/2 because that is greater ang 1. So therefore, we have 2, the square root of 1 minus 4x squared. So this is the final answer. So 2 square root of 1 minus 4x squared. So that's it for number 7. Okay, so we have here, try this. Differentiate y with respect to x, that a is greater than 0. So take note, you have three problems to solve. So I hope everyone, so for listening, so I hope this is quite long because I really have to explain it well, step by step, in order for you to learn. Because if I would have to make it a shortcut, sometimes it cannot be easily grasped by anybody else because we are in different shoot this is time because this is pandemic. Okay, so thank you for tuning into this channel, and I hope you have to share this one in your friends with your friends, ladies and gentlemen. So thank you so much, and God bless everyone. This is Kasaligan Vlogs. Do not forget to subscribe. Thank you, and God bless.